Assalamu alaikum to everyone. Thank you for your presence in this technical session. My name is Taha Hassan Masood Siddiqui and I am here to present the finding of my research titled 3D Object Localization Using 2D Estimates for Computer Vision Application. Before beginning the presentation, I would like to give you a brief introduction about this research. Computer vision based applications have received notable attention due to their interaction with the physical world. In this regard, camera plays a vital role and it is very important to calibrate the camera before creating 3-dimensional or 3D model. The 3D model consists of 3D point cloud usually used to create a 3D model of any object, and the process is commonly known as 3D reconstruction or 3D scanning. 3D scanning is the phenomena of analyzing a real-world object or environment to collect data about its shape and its possible appearance. This collected data can be utilized in the dynamic field of engineering, including reverse engineering, augmented reality, robot mapping, industrial design prototyping, and quality control assurance. Let's take a look at the presentation outline. First, I will discuss about problem statement, what are the challenges we have faced regarding this research. Then, I will talk about proposed solution, which will be followed and to be discussed with the hardware design and workflow of the system. Furthermore, we will take a detailed look at the camera calibration and visualization, which will be followed by the 3D reconstruction technique using structure from motion. And then results of this research to be presented along with the comparison of camera and laser scanner based results, and finally the complete presentation will be concluded. It was very difficult to create 3D model of irregular shape object easily before 3D scanning. It can be observed from this figure that we cannot make a 3D model of irregular shape object easily by using the 3D modeling software. Also, it is observed from this figure that the design captured by 360 rotational 3D scanner doesn't have capability to handle the loss of base data information of the 3D object. Moreover, technical expertise are required to use 3D scanning technology because this technology doesn't have user-friendly environment, and we cannot scan large 3D object at high resolution by using the fixed platform 3D scanners. Indeed, most of the 3D scanners are still pretty expensive, and we know that 3D modeling is a time-taking process to complete the end result of the desired object. To overcome these problems, low-cost solution is presented based on camera scanning technique, and generally camera-based scanners provide highly accurate and real-time visualization. And now we don't need to fix the platform of the system because handheld system is designed to scan the whole 3D object, and also it reduces lead time to scan the 3D model of the desired object. Okay, now let's talk about the hardware design of the system. The hardware implementation of the proposed approach is implemented on HP Core i5 with the high definition camera and MATLAB support packages, and checkerboard pattern with known pattern information is placed at the fixed platform, and cubic box is used for experimental purpose to test the accuracy of the calibration. Once the camera is connected to the computer, a set of test images of checkerboard pattern must be added into the calibrator app. The calibration algorithm then detects the corner of checkerboard pattern to ensure that test images satisfy the calibration requirement, and the calibration accuracy can be evaluated and improved by analyzing the reprojection error, camera extrinsic parameter, and viewing the undistorted image. After the successful camera calibration, the exported camera parameters can be used for various computer vision tasks. First, we need to calibrate our camera before applying to any specific application, and the calibration process uses camera parameters for the correction of lens distortion, measuring the size of an object, and estimating the location of camera in the 3D world, and calculate its extrinsic and intrinsic parameters. The extrinsic parameter contain the location of the camera, whereas the intrinsic parameter hold the focal length of the camera in the 3D world. These two figures shows the calibration process flow and mapping of camera coordinates that I have already explained to you, and this figure depicts the removal of lens distortion, and the undistorted image can be clearly seen in this figure. The 3D extrinsic parameter plot provides a pattern visualization and camera view visualization. The pattern visualization is more helpful when the pattern is placed at the fixed position. On the other hand, camera view visualization is more suitable when the test images are captured by placing a camera at the fixed position. This figure shows the process flow of a structure from motion, and structure from motion is a technique that determines the 3D structure of an object from a set of 2D input images. To find the feature of interest point, SURF, which is speeded up robust feature algorithm, is used, which compare pairwise match of the current image with the previous image. These interest points are helpful to determine the relative motion of the camera that compute 3D location, and at the end of this process 3D dense reconstruction is achieved in terms of 3D point cloud. In this slide, camera based experimental result is shown, and the experiment is performed on the cubic box to analyze the 3D point cloud of this object. To validate the performance of the system, we carried out several experiments to verify its accuracy, robustness, and efficiency. Figure A shows the experimental setup, and the 3D point cloud of the scanning result can be seen in the figure B. Okay, now let's talk about the comparison of camera and laser scanner result. This figure shows the camera based 3D point cloud, whereas this figure demonstrates the laser scanner based 3D point cloud. It can be seen from this figure that there are some outliers in the laser scanner based 3D point cloud, and it is more prone to error. On the other hand, camera based 3D point cloud shows minimum outlier, and it provides reasonable 3D points to enhance the accuracy of the 3D model. In this research, low-cost 3D scanning solution is proposed by introducing the high-definition camera scanning approach, and the proposed technique provides minimum outliers as compared with the laser scanner based technique. And now handheld system is designed to overcome the loss of base data information of the 3D object, including the base information. With this handheld system, now we can scan large 3D object at high resolution. However, majority of related research mostly focus on laser scanning technique, which is high cost solution. This research can raise the awareness of low cost camera based 3D scanning. It may also provide new direction for improving 3D scanning to make it easier, better, and more accessible in the future. Thank you.